That's why the radius stays constant. If the tangential velocity is greater than the hanging weight, then the radius will increase and this weight will rise. If it's less, then the radius will get smaller and the weight will lower, right? So all we need to do in this experiment, since we know this mass, and we know the acceleration due to gravity, and we know this radius, all you have to do is spin it at a certain velocity, not holding the string at all, at a velocity where the radius stays the same, and you time it. And since it's easier with the tools that we have to time 10 revolutions instead of 1, you just time 10 times around, and you write that down. And then, so you do 3 trials, I think, with this mass. And then you do 3 trials where you add 50 grams to this. So you change the hanging weight, and you time it again. So if you change this mass down here on the hanging weight, and this radius stays constant, and this mass stays constant, what needs to change in order? The tangential velocity, right? Because we need to keep the centripetal force equal to the hanging mass. So what's going to happen is it's just going to spin faster in order to account for the extra mass down here. Does that make sense? So all you need to do is to do 3 trials with one mass, 3 trials with the other, calculate the centripetal force, calculate your hanging mass, which you only have to do twice, and then you compare them to find your percent error. And while I have all of your attention, there's an error in your write-up. In the equation for centripetal force, this n is missing, the mass. Make sure you have that, or else you're going to get huge experimental errors.
Wait, is that the mass of the hanging weight?